So I'm going to move into talking about, what is a sensor. Kind of covered that, but I'd like to go a little bit more in depth in it. Again, my name is Benjamin Day. I'm a senior systems engineer with Paessler. When we talk about what a sensor is, it's the core metric in how we define an installation size with PRTG. We go by sensors. So we do in groups of 500, 1,000, 2,500, 5,000, or an XL1, which gives unlimited sensors. So again, the sensor is how we measure something on a particular machine, and it can be something as complex as down here in our VMware installation, our host performance sensor. This sensor gives back a lot of information for a single sensor. I get a full view of an entire host and how it's operating. I get CPU ready, I've got CPU usage, data store read-write latency, disk utilization in megabits per second, disk device latency. I can see memory consumption. I can see how much I've allocated for it, how much I've actually provisioned, how much out of that provisioned amount is actually active. I can get that in whole numbers and percentages. And then I see any swap that I'm using as well. And then down here I can see network received, transmitted, and used. So I can see how this host is affecting my network as well. What I really like about this from the standpoint is it's all together, it makes sense, it's grouped accordingly. And then the same thing applies to the other sensors with VMware. So the same thing would apply to a guest. Again, we get CPU usage, CPU ready, data store read-write latency, disk utilization, memory utilization, and network utilization. So it's the same metrics we're looking at, only now it's applying to a guest instead of a host. Then on the not so common sensors, take for instance on this Synology array here, I have a sensor that tracks whether an upgrade is available or not. This is a custom SNMP sensor. Now this is where we are extremely agile when it comes to being able to create sensors with PRTG. This is a custom SNMP sensor, and the way I set that up is I go out and I get the OID. I could have gotten that OID from anywhere. I could have searched and found a forum result where somebody said, hey, this OID right here will turn whatever value you're looking for. Hey, in this case, it returns a string value. I can take that and I can immediately put it into PRTG and start tracking. I don't have to code it. I don't have to get an add-on for it. I don't have to do anything like that. If I've got the OID, I can plug it in and immediately go to town. We have another variant of this sensor called the SNP Custom Advanced Sensor that lets you do this, but with 10 OIDs all at once for 10 channels in the sensor. So if I wanted to build my own custom system health sensor for a device, and I've got all the OIDs for it, I can group those together in a single sensor, so I'm not using 7 or 8 sensors for it. I'm using one sensor for it. And then once I've got it done, I can clone it or I can add it to a device template. So once I do it once, all the hard work is over. From that standpoint, PRTG can take and manipulate that data very, very easily. So you can see here, this one is just pulling the device. It's getting the return from it that the DSM's running the latest version. So in this case, that's green. In the case of yellow or red, we'd say that there's an available version for download. So it will alert the administrator to say, hey, your Synology array has a firmware update that it can get. That way they take care of it without having to remember to log into the Synology and see. They can actually have PRTG pull for that. So when we talk about the value and all that, when you have other systems out there that monitor by node or by device or anything like that, you kind of get a little hamstrung in the sense that you have 2 nodes, let's say, and let's say one's a SQL server and one's an application server. That SQL server, it may have 20 databases on it. It may have a ton of metrics that you're following because you may have a ton of scripting, all kind of database monitoring. You may be monitoring a lot of vital WMI stats, and you may be monitoring a couple of hundred metrics on that. The other server, being an application server, you may only be monitoring 10 or 15 on that. So from that standpoint, if you've bought 500 nodes, you've just burned 2 nodes right there, and they're completely different from one another in terms of the overall yield that you're getting. However, with PRTG, when you buy a 500 sensor license, those are 500 sensors to spread anywhere you want, any way you want. If you want 500 ping sensors because you just want to monitor uptime, go to town. It's 500 devices you can check up, down on. If you've got a lot of switches that all you want to cover is bandwidth, again, do whatever you want with them. It's very flexible, it's very pliable, it's not rigid. You can make it work for any situation you need.
When you're doing your checks, are you kind of checking for everything that's assigned to that sensor at one time, or are you doing every channel at once and waiting on a response?
Yeah, so when a sensor's being pulled, so like this CPU load sensor, this is a WMI-based sensor that has a WMI query, and that query executes. When we get the return value back, we then scrape that return query and fill in everything. So a sensor's done all at once. All the channels in the sensor are pulled simultaneously. Yeah. Hence why some sensors are a heavier resource burden than others. SNMP, real lightweight, because it's just SNMP get, OID, and then it returns the value. Done and done. Real simple. Whereas WMI or SOAP or something like that, it's all query based. So I have to write this, I have to have a query, I have to send it out, the device has to process that query, send me back a response. It's usually in a query form that I then have to scrape out the results for it on. So the preferred method is definitely do as much as you can in SNMP before you start doing like WMI on a Windows machine. And that's an important note too. Windows has SNMP. You can turn it on as a service and you can pull all the things like CPU, memory, disk, network, uptime. You can pull all that through SNMP. So you don't have to waste WMI on pulling for CPU when SNMP does it much more efficiently.
Is it still in 2016? Because I thought they were trying to get SNMP out of it.
I don't know on 2016. I know in 2008 and 2012 it's still there. I don't know on 2016. We've hinted a little bit on thresholds, but I want to talk now about how those thresholds work in terms of notifications. So we'll go back to this CPU load sensor here. So I've got these thresholds set on my total and my processor one here. On my total CPU usage, I've got an upper error limit of 80% and an upper warning limit of 60%. Now I can populate all these fields. I'm not limited to just an upper or a lower. I can have an upper and a lower. And then I can have a custom message displayed if I hit an error limit or a warning limit. And that message gets displayed up here in this bar that would change color to represent a warning or an error. But when we talk about what PRTG can do once either of those conditions have been met, the first thing we deal with is triggers. Now, a state trigger, that's probably the most common trigger you'll see in a PRTG installation, simply says that when the sensor state meets a certain condition, being down, warning, unusual, or partially down if you're running it in a cluster, for at least X amount of seconds, perform said notification. Now the notifications are in the second spot, I'll get to that in a second, but you can see you basically select what you want it to do in reaction to this. The state trigger also has an escalation point here, so if it's down for X number of seconds, which would be either the same or more than this one, perform this thing and repeat it for every X number of minutes. And then lastly, I have an all clear here, so when the condition clears after a notification was triggered, do this. And of course, no notification means it doesn't do anything. So you're not tied into making it do everything on here. You can just have it do one thing. The other nice thing is I can stack these triggers. I'm not limited to just a single trigger here. I can have as many triggers as I want. So I can build my own escalation tree of having PRTG step through a different notification at a different time interval based on whatever I've set up as my SLA. Triggers can also be inherited. So this CPU load sensor here is a child of the probe device, which is in the device tree. If the parent object or if the group that the parent object was in had a notification at that level, I would see it up here where it's being inherited. And I can turn that off and on here by telling you to only use the triggers below or inherit the triggers from the parent object and use those in addition to what's down here.
Does that show you what's been inherited?
Yes, this section will show you what's been inherited, but we're not inheriting anything.
Okay.
Yeah.
So is there any logic on the triggers, like if ping fails, try SSH. If SSH fails, try SNMP?
No, we don't have any logic on that. You could do that with one of the notifications, but it would execute the notification, and then you would have to have something in the notification to let you know, hey, the ping's not working, but the SNMP is up. And you could do that through like an email, or you could do that through a program or something. Now, I'll get to that now. So when it comes to the notifications that we can do, we give it a name first. That way we know what the notification's doing. We can start it or pause it. We can bind it to a schedule so that it's only active during certain hours of the day. Let's say you've got a notification that kicks off into a ticketing system or a third-party system that's only monitored by people there 9 to 5. So I could put a schedule on this that says, weekdays 9 to 5. If it's outside of that window, it's not going to happen. If it's inside that window, it will execute. And you can add your own custom schedules, so you're not limited to just the ones here. As for the actions we can take, we can send an email. Every network monitoring solution out there can send an email. If it can't, it's not a very good one. We can send a push notification. So we've got iOS, Android, BlackBerry, and Windows mobile apps for PRTG. And once you install it, you can enable push notifications from your PRTG server to your device. So once you check this, all you tell it is what user is, whichever user that is that you're logging in from your device, and then the message that they get. We can send an SMS or pager message. We can do this two different ways. The first way is we can work with companies like PagerDuty or Bulk SMS. PagerDuty has a wonderful write-up on their website on how to integrate PRTG with their system. We have a few that are already built into PRTG where we've already integrated their API. Or if you have another system that just has an API call to it, you can enter in that as a custom API call to them. The other option is there are a few vendors out there that sell IP-enabled SMS gateways. One of them is called the SMS Eagle. It's sold by a company out of Europe. It's a small box that plugs into your network that you put a SIM card into. It has a web interface, and we have a write-up on our website on how to make an API call to that to have it send an SMS message through the cellular network from your premises. So depending on what your level of control is, if you're fine handing it off to a cloud provider, they can send it. If you want to maintain control within your domain, you can have it on a device like that that can put it on the cell network right there. And they also have another model that has redundancy, so it has 2 SIM card slots for it. We can do some catastrophic event kind of things here. We can push to an event log or a syslog or an SNMP trap. So if you have any system set up to collect logging in the case of, a record of last report or anything like that, we can dump out to those. Execute HTTP action. Here's where things get fun. Basically with this, you give it the URL and you give it the post data. The post data can include placeholders. And when I talk about placeholders, what I mean is we can feed in dynamic data from PRTG about the sensor and device invoking this notification. So in the case of CPU load, I can tell whatever system that the CPU load has reached the current level, it's on this device, and it happened at this time. It's not just some boilerplate generic, something's wrong. Now I can feed it, dynamic data that is very descriptive about the event that's happened, the time it happened, and how long it's been down. More than that, sending just to a ticketing system, I could build one of these that's reactionary in terms of trying to alleviate the issue. Let's say the device I'm monitoring is a web-based platform and it has this one issue with it that's a glitch that keeps happening, and the only way to fix it is to execute this API call. You can automate that now with PRTG by monitoring for the conditions for that event and building a notification that executes that API call and maybe sends you an email too so you have a record of it happening. That API call occurs, the problem's solved, and that's that. Rather than you having to get up at 2 or 3 in the morning just to execute a line of script. We can execute a program. This one gets really fun too because we're not limited to just EXEs. We can run We can run EXEs, we can run batch files, we can run PowerShell scripts, we can run VB scripting, com files. So with this, you can execute an executable. You can give it parameters that you want to feed to it. So if it has any switches or anything like that. You can give it alternative credentials as well. So if it's using secure credentials that you don't want to store in PRTG for using to authenticate to things, you can enter them in here, and you can also establish a timeout period. This is how you can add a pretty high degree of automation to PRTG. This is how it can start to work for you instead of letting you know something and then you having to do things. If you're a PowerShell junkie, it's really easy to take a PowerShell commandlet that somebody's done and just paste that in and have it do whatever it does, and then maybe have something at the end that just returns something, or have it send you an email as well. So if you've got this one commandlet that fixes an issue, you can tie that to a notification that responds to a certain condition occurring, and then you can have PRTG shoot you an email, very similar to the HTTP one. We can also utilize the Amazon Simple Notification Service. If you sign up with that, all you do is you just give us your access key, which location you're on, and then the subject and the message that you want sent out. And then we can assign a ticket within our own ticketing system. The ticketing system in PRTG is not going to displace a real help desk ticketing system. If you're using multiple users in PRTG, the ticketing system can be helpful for assigning responsibility to certain issues that may crop up. So if you have one person on the team that's responsible for firewalls or printers or servers or anything like that, that's where you can say, this incident has occurred, this is your responsibility, take care of it. And then it gives them the ability to mark it as completed or fixed or anything like that.